Hi, everyone. My name is Dimitri De Jonghe. I'm from Ascribe, and we recently migrated to BigchainDB. And the story behind it is, well, Ascribe is basically a way for creators to claim ownership. And the way we did this was using the Bitcoin blockchain as an immutable backend. After 1 year of playing around with Bitcoin, creating protocol on top of it, it came clear to us that it's not always that fast. It's not always that friendly in terms of storage. And it definitely didn't feel like a database. So what we wanted to do is actually we want to serve basically all the commands in the world, if that's possible. We want to serve the creators. Creators need to be able to create licenses and issue them to people that want to consume their content. Now, for this, we figured, well, let's create something that scales, something that has all the immutable properties of blockchain and all the good properties from big data. So let's kick off with a 101 on BigchainDB. It's a recent project, so probably most of you won't have heard of it. So basically, these are the things BigchainDB is targeting, and a lot of them are already accomplished. So instead of going to 3 transactions a second, we rather go to 100,000 transactions a second, maybe 1 million. Short latency, a lot of storage, scalable, adding more nodes means adding more performance. Queryability, use it as a database. And of course, decentralization, not one center ownership, but a federated participation. And typically, these are caretakers of a system. So it could be the music industry, it could be diamond industry. We have a few more use cases. How we did that was actually blockchainifying big data. You have other projects that kind of big datafy the blockchain, like Lightning, Raiden, all these things. They do a great job. But we feel like if we can use the man-decades or man-centuries of work that crawled into big data, we already start with a good platform. So basically what we do is we retain the big data performance using Paxos-like solvers and in order to get an ordered log of transactions to get this replicated state machine. And what we add is blockchain characteristics, meaning decentralizations, having nodes to vote on something, to vote on how legal a transaction is, making sure there are no double spends, making sure there is no malicious behavior between nodes and all these things. Immutability, it's append only. It's a database, but we skipped delete, we skipped update. It's just append. And of course, assets. Assets can live on BigchainDB because they use trapdoor functions, digital signatures, in order to change ownership of an asset. And for this, at this time, when we kicked this off, it was, I think, in October last year. Around the same time, Interledger became more public, and we found it's a great match. So we started weaving into the ILP requirements and all the benefits of it. How you can think about BigchainDB is you have, what we use now is FreeThinkDB because it's largely scalable. It has Raft, which is a Paxos-like consensus protocol, and it makes sure you have strong consistency. So this means that every node in the system sees the same order of actions. And on top of it, we create our BigchainDB federation system, which are nodes which have each a RethinkDB cluster, and they make sure there is blockchain consensus. There is the ability to mitigate Byzantine actors by having votes and quora and stuff like that. How we see that the cloud can be decentralized is basically you have an application stack, and developers want to use an application stack as they use a normal web stack. So the apps are on top. Processing power is in the middle, the business logic. And then you have file storage and databases / ledgers. So you can see you can move from MongoDB to, for example, BigchainDB or payment systems in a decentralized way. And if you go even further, you can use things like IPFS for your file storage and Ethereum for your processing power. And then who knows what kind of apps you can create. So that's left to the imagination. Now, knowing kind of how BigchainDB works, I want to move into the part of the assets. Basically, an asset is something that has a chain of ownership. It could be like a coin, it could be anything of value, low or high value. And basically, if somebody owns it, he has the key to unlock the asset. But he also has the power to put a new lock on the asset and to take a lock from someone and say, well, now you are the only one to unlock it. And it goes on and on. And this is how ownership gets transferred. It's like you have a locking script and an unlocking script. In our case, it's append only. So you can't change one asset by itself. You can only append new ownerships. Now, what's an asset? Typically, it's currency. It could be Bitcoins, Litecoin, Dogecoins, Ripple. But we think it's also everything that's intangible. It could be a piece of land title. It could be any kind of IP. Could be any kind of license. It could also be a creation. It could be a movie, a picture, a song. And of course, everything that can be tagged into a supply chain. So this broadens the scope, I think, for Interledger also. So that's one of our missions towards Interledger, making sure that the payment systems work with the Internet of Value in the broad sense of valuable assets. And the good thing was that some clever guys came up with crypto conditions. And it totally fits the locking and the unlocking scripts. What crypto conditions have is a condition and a fulfillment. A condition is something you want somebody to cryptographically fulfill. And then a new owner knows the fulfillment. It could be a signature, it could be the pre-image of a hash, it could be anything you can cryptographically seal. And if you want to see how the crypto conditions fit into the scope of like just private public key, multi-sig, or smart contracts, well, it's somewhere between multi-sig and smart contracts. The thing is, it's not Turing complete in a sense that it doesn't have state. It's more like a Boolean logic. So how does a transaction, I don't know, oh, quite big, so we can kind of read it. But how does a transaction in, let me go one back. So you see a transaction in BigchainDB has 3 fields. There's a fulfillment and a condition and a payload. And this is in a JSON structure. A lot of it is assigned to the condition and some of to the fulfillment. And in between, you have the data field. And how we created the condition is quite simple. We contributed to the crypto conditions library. We create a Python fork. And basically, you can just say, I create a condition. It should be a signature, ED25519. I assign it public key. And you can serialize it into a URI. So that's your locking script. And if somebody wants to fulfill it, he has to prove that he has the private key that corresponds to the public key, and he knows the message to sign. Once you have that fulfillment, you can, again, serialize it, and you get a condition URI and a fulfillment URI, and they're a paired match. If I'm saying something wrong, Stefan, then correct me. One thing is, what's the message to sign? Well, if you look at transactions, what you don't want is some malicious node altering some field somewhere in the transaction. So basically, you want to sign everything inside of the transaction besides the signature itself, because you could keep on doing that and never stop. So basically, the green part of the transaction is everything that's in the message to sign. The only thing that's left out is a fulfillment URI. And this is the thing that BigchainDB nodes validate. This is the thing that the BigchainDB nodes cast a vote upon. They say it's valid, or it's not valid. Moving on. If you want to track the story of multiple assets in BigchainDB, you'll see some ownership change, some provenance, how we like to call it. You can group transactions, then they have an index. And you see how conditions and fulfillments are always paired with each other. It's not only signatures we support, but also hash locks. Imagine somebody wants to create a voucher. You're a company and you say, well, I'm going to give out some free voucher, and they have this secret code upon it. Okay, create a hash of the code, put it on an asset, and if somebody gets a voucher, he knows the secret to the hash, and he can redeem. So these are quite anonymous assets. Only the one that knows the secret can redeem. Signatures, we use the ED25519. I think these are Schnorr signatures are somewhat more efficient, and threshold signatures. And these are really beautiful. They're kind of Boolean logic for multisig, and you can make compound branches of them. If you're interested in these crypto conditions, do check out, you can either switch BigchainDB by Interledger, and then you get full stack and the real thing. If you like Python more, you can just go to our GitHub or pip install, and should be easy to go. Now, we've been experimenting a little bit, and I think one of the questions today was like, how can a ledger provide the security of escrow? Do you have to have a third party that kind of arbitrates and you trust? Well, it seems you don't, if you make a few tweaks. Basically, what we did was, imagine Alice, the red one. Much better. Alice, the red one, owns an asset, and she wants to put it on hold or escrow with Bob, the green one. What you can do is you can have multi-ownership of the asset, a temporary multi-ownership. So basically, they both have a key to unlock it. But Alice has the key. Her key is valid after expiration date, and Bob's key is valid before expiration date. And you can add any kind of other to escort Bob in claiming the ownership by himself. So basically, it's a switch. It's a branch. It's an if-else. If we're before expiration date, only Bob can redeem, else only Alice can redeem. And how to do so? Well, I used to be an electronics engineer, and I think Stefan or Evan showed us how this actually looks like Boolean circuits, and it does. So we created a construction like this. It's basically a binary switch, and you only need one. Well, besides a timeout condition that says, well, expiry time has passed or not, and the nodes will decide upon their own time zone, we created this little thing called an inverter. It's experimental. It's not, because it can only invert facts. It can't invert crypto conditions, like a signature or something. You can't prove something not happened. So, but you can say the inverse of a fact. In our case, it would be saying that expiry time has not been fulfilled or has been fulfilled. So, well, playing around with this logic a little bit, we figured we can compose a crypto condition, a single crypto condition, in order that actually functions like this. So the execute branch is only enabled before expiry time, and the abort branch only after expiry time. And the key element here is this little inverter. These experimental ones are only in the Python branch, and They're only used by BigchainDB. We could see how we can extend it even more, but basically, the last thing we did for crypto conditions are a few utils, like a JSON dictionary serialization, to-dict, from-dict, making sure you can, and if somebody wants to see how your crypto conditions are composed, then a JSON structure is ideal to do so. Another thing is if you have these complex branches and you want to query, update, delete stuff, then you want to have some kind of language to crawl this crypto condition branch. So that's all about crypto conditions. Next thing, so if you support crypto conditions, you kind of speak the language of ILP. And that's natively supported by BigchainDB. The next thing is if you want to hook up to the network of Interledger, then you need some Ledger plugin. You need an interface to communicate with the system or with the network. And yeah, you can find our, so we created something in JavaScript. It's called ILP Plugin BigchainDB. I guess that's a standardized name. And that kind of, it connects to a WebSocket and an API that's provided by BigchainDB. And basically, you can just start on top in your browser communicating with BigchainDB back and forth. You get notifications. You can send assets to people. You can basically do anything you want inside of your browser. It supports like these functions. Important ones are connect and disconnect, sending a transfer, which basically puts things in escrow on your ledger. Fulfill a condition means execute the escrow branch or abort, depending who's the actor. And get connectors, and that's still a bit fuzzy. We have to figure out how how an account, a public key on your system, in our BigchainDB case, has accounts on multiple other ledgers. My feeling is that might be something in a level above. I have a few demos. I think I want to start with the easiest one. I call it on the record. It's the inverse of off the record, meaning everything you say here gets recorded in an immutable database. And this is just to show that you can create assets without them being money. So this would be just a simple message. So when I say, hi, Interledger group, then it takes like a few seconds to get approved by the system. And there it is, very simple. Another one, what we call shared trader. Imagine you have a grid of shares, could be tickets, could be partial ownership of a bigger thingy. And there are a limited amount of shares, and if you click on one of them, you can simply transfer it. So what you probably see is this one will change color. That means it has a new owner. Every color is a different owner. So, and that's a simple way to transfer shares. And this is all based on these crypto conditions. Now, I think the most interesting demo is a little Interledger demo. And basically, it's quite simple. You have Alice and Bob, and Chloe has two accounts. Alice and Bob have their own ledger, or their own different BigchainDB ledger. So I instantiated two ledgers. One is at port 8000, the other one is at port 8001. And Chloe has accounts on both. So what you want to see is Alice can transfer something to Bob. And along the way, things will be put in escrow. And when Bob executes, the receipt will propagate in the other way. Let the demo gods be with us. And so I select Bob, put it in escrow, probably Oh, sorry. Probably have to refresh. Okay. So what you see now is these two assets with an expiry time. That's the expiry time of the escrow. In the meanwhile, Bob and Chloe already have a new escrow, which also expires in the same time. So, for example, imagine Alice wants to cheat and abort. I think my pressing on the buttons. Then, because the expiry time is not due, this abort function should be neglected, and BigchainDB refuses because the crypto condition is not fulfilled. The other thing Bob could do is execute, and he's allowed to because he's still in expiry time. Unless I keep talking, expiry time will die. So, but when I execute, BigchainDB will accept this transaction, and if everything goes well, and you'll see it was quite fast, but Chloe on the other ledger received actually the thingy from Alice. So now you'll see Alice only has 2 assets. Chloe, the exchange, has 4 assets. Chloe on the other exchange gave 1 to Bob. So this is kind of the path of Interledger for BigchainDB. I guess that's it. Oh, no, that's not it. So, I guess in 1 hour or so we'll have a hackathon. And for us, it will be super interesting to see how you can connect fungible assets with payment systems. Our idea is now to just use something like what we call a stream coin. It's basically you get a coin that you can consume for streaming music. So you actually convert dollars versus some intermediate coin, and then for time units of streaming. So basically, this is kind of how it looks. If you give $50 or some fictive coin, you get 1 stream coin. We can think of many other things. This could be assets. This could be, we had a project with diamonds. You can trade diamonds for diamonds and stuff like that. In the end, we want to end up with licenses at some point. But that's further down the road. And if you like to engage in this hackathon with us, we'll give you some infographics on how we think the system could look like. But I'm guessing most of the things are set up. There are a lot of open source repositories we can point you to, and it should be just a click of the button to get started. So that's all for me. Personally, I'm always wondering if you look at fungible assets, which are not cryptocurrency, how to create an internet of value that's not based only on currencies. So in our case, it's typically licenses, but if you can think of other stuff, please. Yeah, Stefan.
I have a quick question, which is maybe a bit self-serving, but like, what were your biggest pain points with like using crypto conditions, and what was the hardest to understand or like the hardest to implement?
The hardest part of crypto conditions, and that's an easy one, was the serialization, the writers, the readers, and the buffers, and the predictors, and the maximum fulfillment length. And there are a few more, especially the threshold conditions, making sure you have a minimum fulfillment thing. So I figured it out by reverse engineering somewhat, but I don't think I already mastered the skill fully. But that was the most challenging part, yeah, definitely. Because with crypto conditions, you have this cool thing that you only have to know about. Imagine you have 2 branches saying, I have a 1 out of 2 multisig, meaning I only need to fulfill 1 of 2 conditions. Then you can just ignore the entire other branch and just use a condition. And you only have to fulfill the branch that you can do. And that's really beautiful, but it's tedious to implement sometimes. But the tests were okay. Yeah.
So, Stefan didn't get into the details of crypto conditions really today, but there is still a relevant video online if you want to look at it. Some of the thinking's changed a little there, but it's a great way if you want to understand more about our thinking behind crypto conditions to get into that detail. I mean, effectively, that's the format that we've standardized on for that condition in the header. So there's a video there from our workshop in February, which is probably not a bad way to get your head around that stuff. We obviously implemented a version of that in JavaScript. Dimi and the guys at BigchainDB have done one in Python. It's probably our priority cross-platform implementation piece because that's the thing that has to be deterministic across platforms. So, if you're running a ledger that is, written in Python and another one in JavaScript and another one in who knows what else, Scala, Java, they all need to understand and interpret conditions and fulfillments exactly the same. So if anyone's interested in looking at an implementation of crypto conditions in another language, we're keen to listen. We're keen to help as much as we can. Here's the guy who wrote the spec. He can help you do it this afternoon.